Good day, viewers at home. Welcome to Mathematics Lab with Mr. Major. In our first lesson, which is lesson 1, I talk about the laws of indices. Now, today I'll be doing lesson 2, and the topic is indicial equation. Indicial equations, which is also known as exponential equations. Indicial equations or exponential equations are equations that involve indices. Now we'll be required to solve for the unknown in the indices. Now I will begin with the first example on the board. The question says that we should solve for x if 2 raised to the power of x is equal to 32. Now I solve. Solution: 2 raised to the power of x is equal to 32. The first thing we are going to do is we compare the two bases. Since the base here is 2 and the base here is 32, you make the greater base, which is 32, you write it in terms of the lower base. What that means is write 2 to a particular power that will be equal to 32. For example, 2 raised to power 1 will give us 2. 2 raised to power 2 will give us 4. 2 raised to power 3, that is 2 times 2 times 2, will give us 8. 2 raised to power 4 will give us 16. And then 2 raised to power 5 will give us 32. That means 2 multiplying itself 5 times is equal to 32. So that means another form of writing 32 is 2 raised to power 5. So that is the first thing I will do here. So we have 2 raised to the power of x equal to 2 raised to power 5, which is still 32. Now, we are done with this question. The moment the bases are the same, we equate the powers. So since the base here is 2 and the base here is 2, that means x is equal to 5. So we say, therefore, our x is equal to 5. That is the answer. Meaning 2 raised to power 5 equal to 32. Now, let us look at example 2. Solve for s if 3 raised to power x equal to 1 over 9. Solution: we have 3 raised to power x equal to 1 over 9. Now, this one is in fractional form. So we need to apply the negative index law. That means we are going to have 3 raised to power s equal to, remember the negative index law says that if a quantity, for example, a, is raised to power minus 1, it is the same thing as 1 over a. So that means 1 over 9 is the same thing as 9 raised to power minus 1. The next thing, let's look at the bases again. This is 3. So we express 9 in terms of 3. Again, 3 raised to power 1 will give us 3. 3 raised to power 2 will give us 9. So 9 can be written as 3 raised to power 2. So we'll be having 3 raised to power x equal to 3 raised to power 2, then times minus 1, because the power here will multiply the power here. We can also write it like this: 3 raised to power 2 like this, then raised to power minus 1. So from here now we have 3 raised to power x equal to 3 raised to power 2 times minus 1. The powers are multiplying each other now according to the power law of indices. 2 times minus 1 will give us minus 2. Again, like the example 1, the bases are the same now. Since the bases are equal, we cannot equate the powers. That means our x is equal to minus 2. You will notice that I am always making references to the laws of indices. If there's any one of them that you don't really know, you can go back to my previous video that I titled Lesson 1, Laws of Indices, and you will understand the laws quite better. Okay, now let us look at question number 3. The question on the board says we should solve for y if 5 raised to the power of y plus 2 equal to 125. Again, the base here is 5, the base here is 125. So we write 125 in terms of 5. So that will be 5 raised to the power of y plus 2 equal to 5 raised to the power 1 is 5, 5 raised to the power 2 is 25, 5 raised to the power 3 will give us 125. So we have here 5 raised to the power 3. Again, you will notice that the bases are now the same. So we can equate the powers. So if we equate the powers, we will have y plus 2 equal to 3. This has turned to a normal linear equation. We know what to do here. We collect our like terms. If we collect our like terms, we'll be left with y here equal to, we have 3 here, then plus 2, crossing the sign of equality to the other side becomes minus 2. That is collection of like terms. When a positive number crosses to the other side, it turns negative. If it was negative, when it crosses, it turns positive. So that means our y is equal to 3 minus 2 will give us 1. That means our y is equal to 1. Let us look at question number 4. Question number 4 says we should solve for n, given that 7 raised to power n minus 3 equal to 1. Now let's look at this. I was saying that we should make the base. I have repeatedly said that we need to make the bases to be equal. In this case, the lower base is 1. We cannot write 7 in terms of 1. But we can write 1 in terms of 7. How? Remember the zero power law of indices. The zero power law of indices says that anything raised to power 0 is equal to 1. That means a raised to power 0 is equal to 1. 5 raised to power 0 is equal to 1. So 7, since we have 7 here and we need to make both sides 7, this is now going to become 7 raised to power 0 equal to 1, because any quantity raised to the power of 0 is 1. So let's solve. So we now have 7 raised to power n minus 3 equal to 7 raised to power 0. And of course, this is still 1. Again, the quantity, the bases are the same. Since the bases are the same, we cannot equate the powers. So we say our n minus 3 is equal to 0. Now, let us collect our like terms. All the numbers move to one side. So we have n equal to 0 minus 3 crossing to this side becomes plus 3. So our n is finally equal to 0 plus 3 is 3. So our n is equal to 3. Okay, we have another question on the board, which is 2 raised to power 3x equal to 32. Please, the instruction is supposed to be solve for x. Solve for x if 2 raised to power 3x equal to 32. So now, this will be 2 raised to power 3x equal to 32 is the same thing as 2 raised to power 5. The bases are the same, so we have 3x equal to 5, because when the bases are the same, we equate the powers. Here, there are no like terms to collect. But we know that in equations, when a letter, an unknown, has a coefficient, we use the coefficient to divide both sides. So we are going to divide, let me write it, divide both sides by 3, which is the coefficient of the unknown. So we have 3x divided by 3 equal to 5 divided by 3. So here 3, we cancel 3. We are left with x. Here nothing can divide into 5 and 3. So we leave it like that. That means our x is equal to 5 over 3. That is the final answer. Or you can write it as a mixed number, which will be one whole number, 2 over 3 as our final answer. Now we have question number 6 on the board, which says solve for s, Given that 9 raised to the power of x plus 1 equals 27 raised to the power of x minus 1. So let me write the question again. 9 raised to the power of x plus 1 equal to 27 raised to the power of x minus 1. The base here is 9. The base here is 27. Now, 9 cannot be raised to any power to give us 27. 9 raised to power 1 is 9. 9 raised to power 2 is 81. That means we have exceeded 27. So that means we need to look for a different number that can work for the two of them. If you look at 9, 3 raised to power 2 will give us 9. Then when you look at 27, 3 raised to power 3 will give us 27. That means 3 can work for both sides. So we use 3. So this 9 becomes 3 raised to the power of 2, then multiplying x plus 1 equal to 27 is 3 raised to the power of 3 multiplying x minus 1. We now apply the power law of indices that says the powers should multiply the powers. So we are going to have 3 raised to power 2 times x will give us 2x. 2 times plus 1 will give us plus 2. Then equal to, we come over here, 3 raised to power 3 times x will give us 3x. And then 3 times minus 1 will give us minus 3. The powers, the bases are the same now. Now that the bases are the same, we can now equate the powers. So that means 2x plus 2, which is the power here, equal to 3x minus 3, which is the power here. The next thing we are going to do is to collect our like terms. If we collect our like terms, we will have 2x. This is 3x. 3x is a positive term. So when it crosses over to this side, it becomes minus 3x equal to, now over here, the number we have here is minus 3, not 3, please. It's minus 3. Now this is plus 2 as a number as well. Plus 2 crossing over to that side turns to minus 2. 2x minus 3x will give you minus x, because when you are subtracting a number with a higher face value from a number with a lower face value, you have a negative answer. So 2s minus 3s is equal to minus s, equal to minus 3 minus 2 will give you minus 5. So now, let me continue the solving from here. Remember what we have last year is minus x equal to minus 5. So now, minus here, we cancel minus, giving us x to be equal to 5 as our final answer. At question number 7, which says we should solve for s given that 3 raised to power x plus 3 raised to power x plus 1 equal to 108. The base here is 3, the base here is 3, the base here is 108. Now, 3 raised to power 1 is 3. 3 raised to power 2 is 9. 3 raised to power 3 is 27. 3 raised to power 4 is 81. Then 3 raised to power 5 is 243. Now, 243 is already more than 108. That means 3 cannot be raised to anything to give us 108. So there is a need for us to trash this. And we can reduce this further. But let's come to this left-hand side. 3 raised to power x plus. If you look at this, we have s plus 1. You remember in the multiplication law, that is the product law, the very first law of indices. If you have something like 3 raised to power x times 3 raised to power 1, since the bases are the same, we will add the powers. So this is the same thing as 3 raised to power x plus 1. So 3 raised to the power s plus 1, which is what we have here, can be splitted into this. So that is exactly what I'm going to do now. We have 3 raised to the power x times 3 raised to the power 1 equal to 108. 3 raised to the power x is common to these two sides because this is addition. So we are having a binomial here. So we can factorize. So we are going to factorize this left-hand side. If we factorize, what is here and is also here is 3 raised to the power s. So we bring it out. 3 raised to the power x. Then we now have 3 raised to the power s divide 3 raised to the power x will give you 1. Plus 3 raised to the power s divide 3 raised to the power s times 3 raised to the power 1 will give you 3 raised to the power 1, which is still 3. Because 3 raised to the power 1 is still 3. Then we enclose our bracket equal to 108. That means what we are having now is 3 raised to the power x times 1 plus 3 is 4. 3 raised to the power s times 4 equal to 108. We can now divide both sides by 4. Because 4 is the coefficient of 3 raised to the power x. It is multiplying 3 raised to the power s, so we can use it to divide both sides. So that will be 3 raised to the power x times 4 divided by 4 equal to 108 divided by 4. So here 4 we cancel 4. Then over here 4 divide 4 is 1. 4 divide 108 will give us 27. So what we are having now is, for the left hand side, the only thing we have left here is 3 raised to the power x equal to, for the right hand side, what we have left is just 27. This 27 cannot be written in terms of 3. So we now have 3 raised to the power x equal to 3 raised to the power 3. Because 3 raised to the power 3 will give us 27. The bases are not the same. So we equate the powers. That means our x is equal to 3. That is the final answer. Of course, you can confirm your answers. If you want to confirm the answer, 3 raised to the power s and our s is 3. That means the whole of this is 3 raised to the power 3, which will give us 27. Then plus, here becomes 3 plus 1, meaning 3 raised to the power 4. And 3 raised to the power 4 will give us 81. And of course, 27 plus 81 is equal to 108. Please let me come back to re-emphasize that 3 raised to the power s times 3 raised to the power 1 is one term. It's a multiplication expression, so it is one term. That is why I grouped this as one term and brought up this during the factorization, that 3 raised to the power s is common to both sides. All right, we will take maybe 2 more questions and we round up for today. We'll be looking at question number 8. The question says we should solve for s given that 2 raised to the power x plus 2 minus 2 raised to the power x equal to 24. Like the previous question we just solved, question number 7. This, we can split this because of multiplication law. So this is actually the same thing as 2 raised to the power x times 2 raised to the power 2. The bases are the same. So when we apply multiplication law, that becomes 2 raised to the power x plus 2 as it is here. So the whole of this is equal to this. Then we now have minus 2 raised to the power x equal to 24. The next thing we are going to do is to factorize. So let us factorize. 2 raised to the power x is here and 2 raised to the power s is also here. So we bring it out to factorize 2 raised to the power x. Then what we'll be having left here, 2 raised to the power s divide the whole of this. That means 2 raised to the power s cancel 2 raised to the power s. We are left with 2 raised to the power 2 minus, then 2 raised to the power s divide 2 raised to the power s will give you 1. So we have 2 raised to the power x into bracket 2 raised to the power 2 minus 1 equal to 24. Equal to 24. The next thing, we now have 2 raised to the power x times 2 raised to power 2 will give us 4. So we have, okay, let me still open our bracket. So we have 4 minus 1 equal to 24. So that will give us 2 raised to power x times 4 minus 1 will give us 3. So we have 3 here equal to 24. Again, the 3 is the coefficient of 3 raised to power s. This is a multiplication expression. So we use 3 to divide both sides. That means we'll be having, let me continue from there, we'll be having 2 raised to power s times 3, 2 raised to power x times 3 divided by 3 equal to 24 divided by 3. Here, 3 will cancel 3. Then 3 divide 24 will give us 8. So 2 raised to power x is equal to 8. And 2 raised to power x is equal to 8 can be written as 2 raised to power 3. So 2 raised to power 3. The bases are the same. So we equate our powers. Our x is equal to 3. Okay.